In this lesson, we're going to talk about measures of central tendency. We're beginning to get into the realm of statistics where we're going to be calculating values on a set of data. These values can give good summary information to help give a quick idea of what the data is actually representing and what it can imply. Let's talk about these three main ones, and we'll discuss more in the future. The mean is the average that you have encountered many times. We even used one when we were doing the average daily balance in a previous lesson. Simply what we do is we add up all the numbers in the set and then divide by however many numbers there are. It's a pretty classic formula that you've seen many times before. The median of a set of numbers is the middle, but we must list the numbers in order to find the median. If there are two numbers in the middle, we will average those two numbers to get the median. And then finally, the mode is the one that's going to occur the most frequently among all the data set. Let's do an example. Let's find the mean, median, and mode of 11 different movie times and the minutes of these movie times. Now, since I'm going to be doing the mean, median, and mode, I'm going to go ahead and put the data in order. However, you could calculate the mean directly just from what you have right here. When I put the data in order, I like to carefully cross things out so that I don't miss anything. I see two 88s, so I'm going to copy those. And the next number appears to be three 90s. And then I see 93, 100, 105, 110, 113, and 155. Now let's calculate the mean. Again, to calculate the mean, you're going to add up all the values and divide by however many there are. For the sake of completion of this example, I'll actually write out all the steps. Here's my calculation. I don't expect to necessarily see anybody write this out, but make sure that you calculate the proper sum when you do this. And by the way, the problem says that these are 11 different movie times. It doesn't hurt just to go back and count these yourself, and also count your rearranged one just to make sure that you didn't miss anything. When I add these numbers up, I get 1,122, and I still need to divide that by 11. It's a pretty good idea to write out your sum, at least that way you're showing enough work that I could check behind and see if there was any mistakes. Now if you divide 1122 by 11, you get 102, and this is in minutes. That's the mean of this data. Now let's do the median. For the median, simply cross out data points on the left and the right, then the left and the right, and continue this process until you're down to something in the middle, or possibly two things in the middle. I see that 93 is my middle number, so 93 minutes is my median. Now the mode. When your data is in order, it's usually pretty easy to spot the mode. The mode is the number that appeared the most times. That number was 90. The mode is 90 minutes, and I like to mention that it appeared 3 times. Let's do another example. First thing I'll do is let's put this data in order. I see the smallest number being a 67, and then we have 77, there's 2 of them, and so on. Again, it's not a bad idea just to double count that you do have 12 data points, which I do. And now let's calculate the mean, median, and mode. When I add up all of my values for the mean, I get 1,027. I need to divide that by 12. And I get approximately 85.58. This time this is a score, so I don't have really any unit to put on it. Now let's do the median. Again, you'll just cross out on the left and the right. You can go more than one at a time if you want, but just keep doing this until you arrive at your middle. You'll notice this time I have 2 values in the middle. So what I need to do is add these 2 values together and divide by 2. I'll calculate their average. And by the way, you really don't even have to do the addition. It's just the number that's between them. So 87 is the median here. And then finally for the mode, there's only one value that shows up twice, and that is 77 for the mode. And just like last time, I like to also specify that it appears twice. Now let's go back and take a look at what we did so far. One measure of center captured the data the best in one problem, and a different one captured the center best in the other problem. Let's go back and take a look. In this example, look at the 102 and the 93. In the scope of the problem, that 102 is much bigger than 93. 102 fits right here in the data set. That's way off center. So the 102 is not a very good measure of center in this case. And there's a reason for it also. If you look through the data, we get an 88 jumps to 90, 90 jumps to 93, kind of big jump to 100, 105, 110, 113, but then the 155. It jumps more than 40 minutes longer. That's what we call an outlier. An outlier can skew your mean. In the second example, the mean and the median were rather close together. The 85.58 is just a little bit off center, and that's okay. As long as the mean and the median are pretty close together in terms of how far apart the data is, that's okay. If the mean is not skewed like it was in the last problem, then the mean is a great choice. Let's write down what I was just saying for this. In the first problem, the mean was skewed by the outlier of 155 minutes. Thus, the median is the better choice. And while we're on this topic, let me give you another example. Average household income. This number is used for a lot of different government purposes. It is nice to know what is the average household income. The problem is, if you were to actually use the mean average of how much people make, there are some people in this country that make a lot of money. A lot more money than all of us do. There are billionaires in this country. And so because that one person has so much money, they skew the mean average so that it looks like all of us are making 6 figures, maybe even close to 7 figures every single year. And you know that this is not the average household. So what is a better thing to do? Instead of calculating the mean when you're looking at income, calculate the median when you're looking at income. The median household income is a good averaging number in order to get a feel for what the average American faces in terms of income. In the second problem, since the mean was not skewed, we'll use that value since it used all of the data. If the mean can be used, you should use the mean because it captures all of the data, whereas the median really only looks at what is the middle 1 or 2 pieces of data. It is useful to use the median when the mean is no good, but it's better to use the mean if you can. Let's look at an interesting example of a mean. Consider 1-pound weights placed on a seesaw marked with the number line. Let me draw you a little picture of what this looks like. Imagine these weights placed on the number line. You've got a weight at 3, you've got 2 weights at 5, you've got a weight at 8, and you've got a weight at 9. Where should we place the fulcrum so that this seesaw is balanced? One of the properties of the seesaw is wherever you put the balance, the farther you are from the balance, the more torque it causes. So let's say I were to put the balance at 5. At 5, you would have this contributing nothing because it's at the center. The 3 would contribute something, but compared to how far away these 8s and 9s are, they would push a lot harder. Imagine you're on a seesaw with a child. You have absolutely no way for that child to push you down, but there is a way to actually make it work when you're not on the ends of the seesaw. If you were to move much closer to the center of the seesaw, you could actually play with the child and they could do it just fine going up and down with you because they're so far away from the fulcrum that they can actually pick you up. That's a property of a lever. Aside from that, what it turns out is calculating the means of these values will actually tell you exactly where the balance would have to be. Let's calculate that mean. Here's the values that are going into the problem, and if we add them together, we get 30 divided by 5, which is 6. With that said, if I were to place my fulcrum at the 6, then this system would actually be balanced. Let me give you a little bit more reason as to why it's balanced. The 8 being 2 steps away is equivalent to 2 weights being 1 step away. Then you'll notice that the 3 is 3 steps away and the 9 is 3 steps away, so they balance each other out. For one final example, let's do the mean, median, and mode on a frequency chart. The left side of the frequency chart is the data that I'm wanting to average. The right side shows how many times it appears. Since this is the number of days that you have to wait to get married after applying for a marriage license, this will tell us the average wait throughout the whole country. If we were to add this up, 0 occurs 25 times. We really don't have to write that down, but I'm going to do it for the sake of completion. 1 day occurs 1 time. 2 days occurs 1 time. 3 days occurs 19 times. 4 days occurs 1 time. And 5 days occurs 3 times. And then we're going to divide by how much is in here. Now, you probably know that there are 50 states, but it would be wise to just double check by adding up these numbers. The 25, 1, 1, 19, 1, and 3, if we add those up, we do get 50. When I add these up, I get 79 divided by 50, which turns out to be 1.58, and this is in days. Now let's calculate the median. Pay careful attention to the steps on this one. Imagine that you're looking at the data written in order. You've got 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. There's 25 of them. Then you see a 1, a 2, a bunch of 3s, a 4, and then 3 5s. So I'm going to start canceling on the left and the right of this imaginary long list of data. If I cancel 3 of the 5s on the right, then I would cancel out 3 of the 0s on the left. That takes me down to 22. Then I could cancel out the 4 on the right with another 0 on the left, which takes me down to 21. Then I've got 19 3s on the left side that I can cancel out with 19 0s on the right side. That leaves me with 2 0s. Then I cancel out the 2 with one of the 0s, and I now have 1 0 remaining. Here's a picture of what this looks like. At first, I canceled out the 3 5s with these 3 0s. And then I canceled out the 4 with the 0s. And then I canceled out a bunch of 3s, 19 of them to be precise, and I was left with 2 0s, so that sort of cancels out all of this. Then I've got just this left over. The 0 and the 2 cancel out, and I've got a 0 and a 1 remaining. With that said, if I average the two, 0 plus 1 divided by 2 would be 0.5 days. And then finally the mode. Again, the mode is just the number that shows up the most frequently. In a frequency chart, this is very easy. Just look at which one had the highest frequency, and it was 0. 0 days.